This presentation will focus on the U-CERT Tool 1, named the U-CERT Comparison and Calculation Toolkit for National Annexes, which is part of a set of tools to be developed under the U-CERT project Work Package 5 that ISO is leading. This tool enables cross-comparison of member states' national choices in relation to the overarching EPB standards EN ISO 52000-1, and it will be discussed in more detail in the next slides. The content of this presentation has been prepared by Niccolo Mignani, civil engineer working at ISO in the Netherlands. The idea behind U-CERT Tool 1 is to assess the choices made by each member state on the tables selected as important factor for the calculated energy performance in U-CERT Task 3.1. These tables are part of standard EN ISO 52000-1, the overarching EPB standard that provides the general framework of the EPB assessment and that establishes a systematic, comprehensive, and modular structure for assessing the energy performance of new and existing buildings in a holistic way. Here is reported a list of all the tables belonging to EPB standard EN ISO 52000-1 which have been selected as important factor for the calculated energy performance in task 3.1 and that are assessed and compared in the U-CERT Tool 1. Thus, based on the tables selected in task 3.1, member states' national annexes of EPB standard EN ISO 52000-1 have been collected. Some of them are available on the EPB Center's website, while others have been filled in for the U-CERT project. In any case, this information can be obtained via the U-CERT General Questionnaire on standard EN ISO 52000-1 that was conducted throughout the project. The assessment of these tables was then carried out in two ways. For some of them, using a set of simplified spreadsheets, which have been translated into a digital tool. This set of spreadsheets was the result of a work in parallel with some of the EPB Center experts, and they allow to carry out what is described in the standard. For the other tables, always selected in task 3.1 and belonging to standard EN ISO 52000-1, but which are not covered by the simplified spreadsheets, the assessment has been done by making a cross-comparison of the member states' choices made on these tables. Additionally, as a result of a deep study of EPB standard EN ISO 52000-1 and multiple meetings with the EPB Center experts, helpful material has been written and compiled in an explanatory report for each selected table. Both the cross-comparison paper and the explanatory report are connected by links which can be found in the digital version of the simplified spreadsheets. Let's start analyzing this set of simplified spreadsheets. First of all, it is important to bear in mind that this set of spreadsheets was created with the intention of assessing the impact of certain national choices linked to EPB standard EN ISO 52000-1 and with the final aim of translating these spreadsheets into a web environment. Therefore, they are intentionally simple and do not allow for the assessment of a huge number of tables. By the way, the logic behind these spreadsheets is to consider a default building, a single-family house with an intermediate climate, for instance, the one present in northern Italy, where heating, cooling, and domestic hot water uses are taken into account. An hourly calculation procedure is used for 2 days of the year, a winter and a summer one, in order to simulate the two extreme conditions. The spreadsheets used allow to assess the impact of choices made on ISO 52000-1 tables, AB16, the weighting factors, AB17, the key exported factor, AB24, the perimeter choice, and AB27, the basis for the energy performance of buildings. Thus, the needed information to perform this assessment are just the national choices on weighting factors, key exported factor, perimeter choice, and basis for the energy performance of buildings. A total of 5 spreadsheets were used, covering different combinations of building services and technical systems. So, covering space heating and domestic hot water needs, there are this set of spreadsheets served by these reported technical systems, which may be a gas boiler or a heat pump, combined with thermal solar collector and photovoltaic panels. While covering space heating and cooling, there is this other spreadsheet served by a heat pump and the photovoltaic panels. Here it is reported an example of one of the simplified spreadsheets. This is the one with heat pump plus thermal solar collector and photovoltaic panel. The two tables below the graphic depict the energy balance steps A and B, which are dependent on the key exported factor. As can be seen, these spreadsheets produce the following results: non-renewable, renewable, and total primary energy, the renewable energy ratio, and the final CO2 emissions and cost values, always expressed in terms of primary energy for both steps A and step B.
Welcome everyone to the Digital U-CERT Tool 1, which is the translation into web environment of the simplified spreadsheets we have already discussed about in the previous slides. Let's start from the selection of the system configuration we want to take into account. As we have already seen, we have this collection of combination of technical systems that can be composed by a gas boiler or a heat pump with photovoltaic panels and thermal solar collectors. By changing the combination of the technical system, we get the corresponding results in the picture here on the right. This combination of technical systems satisfy the heating and domestic hot water needs of the building and as well as the heating and cooling needs of the building. Let's start from the gas boiler with photovoltaic panels and thermal solar collectors. The second step of the analysis is the selection of the annex we want to take into account, and here we have a list of the annexes we can select. This list will be implemented covering all the 11 partner countries involved in the U-CERT project. Let's start selecting the U-CERT annex, and so let's start from the U-CERT choices on the tables that can be assessed through this simplified comparison, which are table AB16, table AB17, table AB24, and table AB27, as we have already seen. Before assessing these tables, we should select which day of the year we want to take into account, so a winter one or a summer one, and which hour of the day we want to assess. By changing the hour of the day, we get different values in kilowatt hours on the arrows representing the energy carriers involved in the building's energy balance we are currently studying. So now we can start assessing the first table, table AB16, the one related to the weighting factors. Weighting factors are needed to convert, so to weight the delivered energy demand required to meet the building needs into primary energy demand. And further information on this table can be found in the explanatory report, which is part of U-CERT Tool 1. These values reported in this table are those selected under the U-CERT project for this type of energy carriers corresponding respectively to non-renewable primary energy factors, renewable primary energy factors, total primary energy factors, and CO2 and cost conversion factors. It is also possible to edit this table, and so to decide the values to assess for each energy carrier. For instance, it is possible to select our own value for non-renewable primary energy factor for the grid electricity. So for instance, instead of 2.3, we could select a value equal to 1.5. And this can be done for each energy carrier and for each type of primary energy factor, so even for cost and CO2 conversion factors. Then the selected values will be shown in this table. In the table here on the right are displayed the results of the building energy balance that we are currently studying and that depend on the weighting factors values. In the first row, so in this one, are displayed the values that we can find in the picture of the kilowatt hour of each energy carrier involved in the building's energy balance, and that are needed to satisfy the building needs. Then, in this other row, we can find the value obtained multiplying each value of each energy carrier to the corresponding weighting factor. While in this column, so in this one related to the total one, we can find the final value, which are the results of the sum of all the values reported in the same row, for instance, in this one. Here on the right we have two different tables. So the first one is related to the step A of the building's energy balance, while the second one is related to the step B, which depends from the key exported factor that we will see now. So now we can go to table AB17, related to the key exported factor that is used to control which part of the exported energy is included in the energy performance of the building. And further information on this table can always be found in the explanatory report linked to the tool. User's choice on this factor is to set the key exported equal to 1, which means that the key exported energy is now included in the building's energy balance. Actually, this factor may assume any value between 0 and 1. If it is set equal to 0, the exported energy is not included in the building's energy balance, while if it is set equal to 0.5, for instance, the exported energy is included in the energy balance for a key exported factor equal to 0.5. As we can see, in this related table related to the step B of the building's energy balance, by changing the value of the key exported factor, we get different results. If key exported is set equal to 0, like as it is now, in this table we will get the same result that we have in the table related to the step A of the building's energy balance, where the key exported is not involved. While if key exported assumes any value greater than 0, these two tables will be different. Then we can go to table AB24. This table, as for table AB27, does not affect the results of the building's energy balance, as do tables AB16 and AB17. Table AB24 gives informative default values for defining the perimeters for the renewable energy ratio. It specifies whether or not to include nearby and distant in the calculation. The first two columns are for the calculation of the renewable energy ratio, while the third one specifies if delivered energy from on-site, nearby or distant are taken into account within the building's energy balance. As for the first two tables, even for this one, further information can be found in the explanatory report. These are the choices made under the U-CERT project. and it means that the renewable energy ratio taken into account within the U-CERT project is this one, corresponding to these values, which is in this case for this day of the year, but especially for this hour of the day that we previously select, is equal to this other value of the renewable energy ratio. That would be considered if in the first column of this table even the renewable energy delivered from distant would be taken into account. Let's analyze now table AB27 that specifies which parameters should be considered for these types of assessments. The user's choice is to consider for each of them the non-renewable primary energy indicator. So in the step A, the user choice is to consider this value, while in step B, where the key exported factor is involved, is to consider this other value.
Now let us examine the cross-comparison of member states' choices made on these reported tables that are not covered by the simplified spreadsheets previously seen and that have always been selected as important factor for the calculated energy performance in U-CERT task 3.1 and that belong always to the standard EN ISO 52000-1. For these tables, a document listing and containing all of the gathered choices made by each member state has been generated, as well as for the tables covered by the simplified comparison. An explanatory report has been prepared even for these tables with additional information and explanation related to each of them. In this slide, we can see an example of a cross-comparison between U-CERTs and Italian choices made on table AB18. That is one of the tables listed in the previous slide belonging to standard EN ISO 52000-1 and selected within U-CERT task 3.1. This table is related to the building services considered in the energy performance calculation. As can be seen, these two tables are pretty similar, apart from people transport services which are considered in Italy within the energy performance assessment for non-residential buildings but are not for U-CERT. Thus, this cross-comparison allows the identification of differences between countries or with the choices made under the U-CERT project. Finally, the U-CERT Tool 1 includes an explanatory report, which is composed by introductions, explanations, additional information, linked tables, and user choices made for each table selected within task 3.1 as important factor for the calculated energy performance and that have been assessed in U-CERT Tool 1 thanks to the simplified spreadsheets and also thanks to the cross-comparison, as we have already seen in this presentation. Moreover, this explanatory report contains an introduction to the set of EPB standards with links to extra material if further information are requested. This is everything from my hand. Thank you for your attention and feel free to follow up on the results of U-CERT project through the website and through other communication channels.